Yeah, good morning students. In this video, I will be discussing on the basic concepts on analog and digital signals. Let's see first what is analog and digital signals, what are composite and non-composite signals. Then we will see about the sine wave and what are the basic characteristics of sine wave and a few problem statements on sine wave. So as I mentioned here, data can be analog or digital. The term analog data refers to information that is continuous. So continuous in the sense, here the data can't be measured. It is infinite. So digital data refers to information that has discrete states, means where it is countable. That I will show you in diagram. Next slide. Analog data, as I told you, takes on continuous values, which is infinite values, whereas digital data can take a discrete values where you can count. So here I can show you some pictures, like these are all related to analog and these are all digital, and here you can see some analog signals that can be transmitted through headphones, speakers, and these are all some digital watches, something just to show the different devices how the analog and digital data is transmitted. So here you can see the first diagram. This is analog signals where you can see the infinite values with various different amplitude and frequency where you can't easily measure. Whereas if you see that second diagram, that is digital signals where there is a limited number of values, means easily you can count it. Okay. So now let us see what is periodic and non-periodic signals. A periodic signal completes a pattern within a measurable time frame. We call it as a period. Means what I am meant to say, a periodic signal always repeats its pattern after an unit period of time. Whereas whereas a non-periodic signal changes without exhibiting a pattern. So what I meant to say here, in non-periodic signals, the pattern can't be repeated every unit of time. Here you can see the diagram. If you see the time and frequency domains of a periodic signal, this is periodic because if I take, this is my time slot, like this one, you can see the signal is repeating here. If this is my signal, so every time the signal is repeating the same pattern every unit of time. So this is the time and frequency domains of periodic signal. You can see the time with respect to frequency. Okay, so first one is having, and the second one, the time and frequency domains of non-periodic signals. You can see here the pattern is not same, it is changing every time. Okay, that's what the definition says. A periodic signal in the sense, the shape of the signal, what I mean to say, the pattern will repeat every unit time, whereas a non-periodic signal, the pattern will be changing with respect to time. So now let us see what is sine wave. The sine wave is the most fundamental form of periodic analog signal, because if you see this is my unit time, every 1 unit time you can see the signal is repeating. That's why I can say it is a periodic signal. So every unit of time the shape of the signal or the pattern of the signal is same. It may be the frequency domain or whatever, it may be amplitude, everything. So the sine wave is the most fundamental form of periodic analog signal. It is a simple curve. Its change over the course of cycle is smooth and consistent. It is continuous, rolling flow, something like that. Okay. A sine wave can be represented by 3 parameters, as I told, the 3 characteristics. One is known as the amplitude, the frequency, and the phase. Let us see what is amplitude, what is frequency, and what is phase. So here you can see the definition. The peak amplitude of the signal is nothing but absolute value of its highest intensity proportional to the energy it carries. So for example, here you can see this one is nothing but the amplitude, means this one is nothing but the voltage or amplitude, I can say this is the highest peak of voltage that it is carrying. If I say it is 10 volts, then the sine wave is carrying with a frequency of, with an amplitude of 10 volts. Okay, that's what the meaning amplitude. So the phase, the term phase describes the position of the waveform relative to time zero. So position in the sense its angle. Here you can see. So the position is here 0 degree. So at what degree the wave is moving, that we call it as phase. It may say either the signal may start from the 0 degree, or it can start from here 90 degree, or it can go with the half cycle or 180 degree like this. So whichever the position the wave is moving, that we call it as a phase. Next we have frequency. Frequency is nothing but rate of change with respect to time. So here you can see the frequency. I will show you in the diagram. So just these are three definitions. Amplitude is nothing but the voltage, phase is nothing but the angle, and frequency is nothing but the number of cycles per second. So here you can say a signal with a high peak amplitude means here. So here you can say a signal with low peak amplitude means low voltage here, like 5 volts or something like that. Here it is 10 volts, or it may be go with still higher peak like 15 volts. So like that, this we call it as the amplitude. So now frequency and period are the inverse of each other. Okay. So if you see here, a signal with a frequency of 12 hertz. As I already told you, frequency is nothing but number of cycles per unit time or per second. Here you can see in 1 second how many cycles the wave is moving. If you see this is one cycle, there you can, if you count, you can see there are 12 cycles. So the frequency is 12 hertz. So number of cycles. Whereas period is nothing but reciprocal of frequency. Here I have given the formula. Frequency is nothing but 1 by t. So if I say that the frequency of the signal is 12 hertz, then its time will be 1 by 12. Means every cycle is taking 1/12 of a second to complete, and in 1 second it is taking 12 cycles to complete. That's what's the meaning. Okay. And here you can see, here the frequency is in 1 unit time it is taking 6 cycles in 1 second. Okay. So time is nothing but, period is nothing but 1 by f. So every 1/6 of the second, one pattern it is happening. That is the meaning. So t is nothing but 1 by f. Here f is nothing but how many cycles? 6 cycles, 1 by 6. So it's nothing but period is 1/6 of a second. Every cycle is repeating. So like that, period and frequency is always reciprocal to each other. So here is a small problem. So the power we use at home has a frequency of 60 hertz. So normally in Europe it is 50 hertz. So it's just telling find the period. So as we already told, period is nothing but time, which is nothing but 1 by f, reciprocal of the frequency, and is given frequency is 60 hertz. So I am just writing 1 by 60, which is nothing but 0.0166 seconds, or I can say 0.01166 milliseconds. So 10 power 3 I am converting, which is nothing but 16.6 millisecond. Okay. So here is one more problem. He has given now the period. The period of the signal is 100 milliseconds, and he is telling to find the frequency. Same problem. In kilohertz he is asking. So frequency is nothing but 1 by t, and has given time in milliseconds, converted it to seconds. You get the frequency, converted into kilohertz. So here I have written that. So f is nothing but 1 by t. So here 100 milliseconds is the question now. So I have just converted into seconds, which is nothing but 10 power minus 1 second. I am just substituting that in the time domain. 1 by 10 power minus 1. You will get 10 hertz. So since he told to represent it kilohertz, I am just writing 10 into 10 power minus 3 kilohertz, which is nothing but 10 power minus 2 kilohertz. Okay. Hope so understood. So here you can see I am representing all the 3 parameters here. There are 3 sine waves with the same amplitude and frequency, but different phases. So I am talking about now phase. Here you can see, as I already told you, phase is nothing but the angle that the signal is moving. Here you can see it is moving at 0 degree. Here it is moving at 1/4 of the time. You can see here it's starting here, and here half of the time slots, means 180 degree it is moving. here it is moving at 90 degree, and here it is moving at 0 degree. This is nothing but the phase. And the last one is the wavelength. The wavelength is nothing but a distance a simple signal can travel in one period. So if you see, this is one time slot, then this I can say it's a wavelength, one cycle. Okay, what is telling the distance that the signal travels in one period of time, we call it as the wavelength. So here if you want to calculate the wavelength, it always have a proportional to period or the frequency. So here is the formula. If you want to find the wavelength, always it is speed and period, or I can say propagation speed into period. We already know that period is nothing but time, which is nothing but 1 by t. So that's what I am writing here, speed divided by frequency, because speed is reciprocal of frequency. So normally this wavelength is represented by lambda, which is nothing but c by f, where c is nothing but speed divided by f is nothing but frequency. So you can calculate the wavelength of the signal with the help of this formula. So here is a small problem statement. So the wavelength is normally measured in micrometers. So it's just asking, find the wavelength of the red light. So normally the color of light, which is red, will have the frequency of 4 into 10 power 14 in air. So he is telling to calculate the wavelength. So wavelength, as we already have the formula, lambda is equals to c by f. So he has given the speed of light, we know already, 3 lakhs kilometers per second. So I am represented 3 into 10 power 8, which is constant, divided by, he has given the frequency 4 into 10 power 14. Just to do the calculation, you will get 0.75 into 10 power minus 6 meters. But as I already told you, normally the wavelength is represented in micrometers. So it is 0.75 micrometers. So this is how you need to find the lambda whenever they have given the frequency. So however, the speed of the light is constant, okay, which is 3 lakhs kilometers per second. And the last one is bandwidth. So by the bandwidth of a composite signal. So what is composite signal? It is a signal which has the n number of different other signals with the different frequencies. Okay. So the bandwidth of a composite signal is the difference between the highest and the lowest frequencies contained in that signal. So the highest frequency signal minus the lowest frequency signal will get you the bandwidth. So if you see this diagram, so a composite signal consists of n number of signals with various frequencies, you can see here. So this is having some voltage, these are having some voltage, so these are the peak voltages. Like that, this overall composite signal is having n number of signals. So if I want to find the bandwidth, you just see the highest frequency. The highest frequency is 5000 and the lowest frequency is 1000. Just you do the difference, 500 minus 1000, you will get 4000, which is nothing but your bandwidth. So here also same thing. This is for non-periodic signal. So this is periodic and this is non-periodic, where the signals can't be measured, which is continuous. So here you can see the highest frequency is 5000 and the lowest frequency is 1000. So 5000 minus 1000 is 4000, which is nothing but your bandwidth. So here is one small problem statement. If a periodic signal is decomposed into 5 sine waves, so it's just telling there is one composite signal which consists of 5 sine waves and has given the frequencies of each sine wave. Like one is 100, here you can see the first frequency is 100, the second one is 300, the third frequency is 500, 700 and 900. Okay, what is its bandwidth? And is also telling draw the spectrum assuming all the components has a maximum amplitude of 10 volts. Here you can see 10 volts. I am just representing all the frequencies with 10 volts. So how to find the bandwidth? Very simple. Which is the highest frequency? 900. Which is the lowest frequency? 100. So 900 minus 100 is 800. So the bandwidth is 800 Hz. Okay. So this is one more problem statement. Here he has given a non-periodic composite signal. So previously he has given the periodic, but now he is talking about the non-periodic, and he is telling the bandwidth is 200 kilohertz. So he has given the bandwidth now. Already we know that bandwidth is nothing but highest frequency minus lowest frequency. Okay. So now he has given the bandwidth and he has given the middle frequency as 140 hertz. So middle frequency is given, okay, which is nothing but 140 kilohertz. So now he is asking, and all are having with the peak amplitude of 20 volts. So here I am representing with 20 volts, which is peak amplitude. So the two extreme frequencies has an amplitude 0. He is telling that these two, means lower frequency and higher frequency, is having the amplitude as 0, whereas the middle frequency is having the amplitude of 20 volts. So this is what your middle frequency, and this is low and high. So now what is telling, draw the frequency domain of the signal. So if I want to draw the frequency domain, so middle frequency have, they only given 140 kilohertz. But what is lowest frequency and highest frequency? So the hint he has given is bandwidth. So he has given bandwidth is 200 kilohertz. Now you need to assume the highest frequency and lowest frequency in such a way that if you do the difference, you should get to 200 kilohertz. And if you do the middle frequency, means low plus high divided by 2, you should get the middle frequency. So you can assume the highest frequency is 240, okay, minus, and the lowest frequency is 40. So if you minus 240 and 240 minus 40, you will get to 200, which is nothing but your bandwidth. And if you add it and divide by 2, then you will get 280 by 2, which is nothing but 140, which is nothing but your middle frequency. Then easily you can draw the spectrum. So now the lowest frequency will be 40 kilohertz. The highest frequency is nothing but 240 kilohertz, which is of amplitude 0. They have only given, so I am representing at 0 voltage. And the middle frequency is 140. As they told, 20 volts is the peak amplitude for this. So just I am drawing the spectrum like this. So these are all the signals which are inside. Okay. So this is how you can find the lowest frequency and highest frequency, and you can draw the spectrum. So in the next video I will be explaining about data rate limits. So hope so you enjoyed the video. I think you got some idea about what is digital signal, what is analog signal, what is continuous, what is discrete parameters, what is a composite signal, what is a non-periodic signal and periodic signals, and what is a sine wave, which are the three parameters of sine wave, that is amplitude, frequency and phase. And also I have shown you few problem statements related to bandwidth, how to find the bandwidth, how to find the frequency, and how to find the time, all those things. Hope so enjoyed the video. Thanks for watching, and subscribe my YouTube channel for more videos. Bye.